Good evening, folks. We have come to the end of Unit 9 in Mr. V Teaches Math, and we happen to be looking at probability. And so our goal for today is to find what's called the theoretical and the experimental probability of an experiment, and to also conduct mathematical experiments. Now, you might be asking yourself, Mr. V, theoretical probability, experimental probability, what is that? I'm glad that you asked. This is what it is. Theoretical probability is basically, the technical definition is a measure of the likelihood of an event based on calculations. You remember yesterday that we talked about rolling a die and tossing a coin, and what are all the possible outcomes? If you take that a step further, you start thinking about, we noticed that there were 12 total outcomes. The likelihood, theoretical likelihood of rolling a 4 and tossing a head, we say that that's 1 in 12, because you have 12 possible outcomes, and the number of favorable outcomes that we're looking for, heads and 4, is one of those options. So the probability is 1 out of 12. Now to switch it up a little bit, experimental probability is like you've calculated the theoretical probability, and that's actually doing the experiment. Say you roll a die and toss a coin 25 times. How many times did you toss a head and roll a 4? So that goes up there, and then if your bottom number is the number of times that you do the calculation. Okay? So for example, the theoretical probability of rolling a 4 and a 6-sided die is, we write it like this: P, and then in brackets, it's the what we're looking for. The theoretical probability, P at 4 equals 1 out of 6. But that's your chances. Now you can calculate that as a percent. It's actually about 17%. The 17% chance of rolling a 4 on a 6-sided die. Okay. So a couple more examples to look at for a second. If you look at this, you have 8 different sections. They're all evenly spaced. So I'm curious what the probability of spinning a 2 is. So you write it like this: P, and then this is what you want. So P and in brackets 2. There are 8 choices, and the favorable one is 1. And all outcomes are equally likely. So this is the theoretical probability, the possibility or probability of spinning a 2 is 1 out of 8. Well, then what about probability of spinning a 3 or a 5? Well, the P probability of spinning a 3 or 5, so 3 and 5 in brackets, is 2 out of 8, or is 1/4. So you actually have a 25, because you can convert 1/4 to 25% chance or probability of spinning a 3 or a 5. This is still theoretical probability. Okay, experimental probability would be actually having the spinner and then spinning the arrow to see where it lands, and doing that experiment 100 times to see where everything lands. Okay. Anyway, let's imagine the scenario for a second. Let's say, for example, that Dylan and Olivia are buying tickets for a pizza lottery. Let's assume also that the tickets are numbered from 1 to 100. Dylan decides to buy all the tickets that are multiples of 10, and Olivia buys all the tickets that are factors of 32. What's the probability of each student winning the lottery? Okay? And so, if you start thinking about this, multiples of, not 100, multiples of 10, you would have 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay? Those are the multiples of 100. So you have, just for a second, okay, so you have the number of tickets that Dylan bought, over number of tickets total. So over here, number of tickets total. So Dylan bought 1, 2, 3, 4, 5, 6, 7, 8, 9. He bought 10 tickets out of 100. And so he has a 1 in 10 chance of winning or a 10% chance of winning. Okay? So the probability, that's how you write it. Probability, Dylan winning, equals 1 in 10 or 10%. You can write it either way. Fraction or percent works fine. Okay? So he has a 10% chance of winning. Now, Olivia bought all the tickets that are factors of 32. So if I make a factor rainbow, I have 1 in 32. I have 2 in 16. 3 doesn't go. I have 4 and 8. And that is it. So Olivia buys 6 out of 100 tickets, which actually give her a 6% chance. So the probability of Olivia winning is 6%. So that's how we calculate probability. Okay, and that's what you're going to be asked to do in the questions for tomorrow's practice. So I hope that makes sense. Have a great night, guys.